Hello everyone. In this video I will be discussing the characteristics of the object-oriented approach. In our course, ISDS 406, we will not be utilizing the OO approach in our semester project, but I do want you to be familiar with it and some of the terminology associated with it. The learning objectives for this video are as follows. First, students should be able to explain the basic concepts of the object-oriented approach. And secondly, students should be able to explain how the object-oriented approach is applied to the system's development lifecycle. Let's start with some key definitions. The object-oriented approach views the system as a collection of self-contained objects, including both data and processes. Object-oriented systems focus on capturing the structure and behavior of information systems in modules called objects that encompass both data and processes. You'll notice that this slide twice mentions both data and processes. This is opposed to the traditional approach, like we're taking in our course, sometimes called the structured approach, where data and processes are listed and modeled separately. For example, we have our process model in a data flow diagram and our data model in our ER diagram. Here are some more key definitions. A class is the general template used to define and create specific instances or objects. An object is an instantiation of a class. An object is a person, place, event, or thing about which we want to capture information. Each object has attributes that describe information about the object. These ideas should seem familiar to you after studying database concepts in ISDS 402. Here's an example. A class could be a customer. A customer has certain attributes such as a name, address, email, and phone number. An object is a specific instance of that class. So, Teresa Marks, who lives at 50 Winds Way, Ocean City, New Jersey, is an object or an instance of the customer class. A vehicle is a class, and vehicle number 913, AC 947, etc. is an instance of the vehicle class. In addition to holding data attributes, objects can also hold information about methods. Methods implement an object's behavior. A method is an action that an object can perform, and messages are information sent to objects to trigger those methods. Let's go back to our customer class example. In addition to the data attributes the customer has, like name, address, email, and phone number, a customer object can also include methods, such as insert a new customer or delete a customer. When we send a message to a class, such as insert a new instance, that will execute the insert method. Again, you can see the difference between these objects and the entities we use in ER diagrams, because in addition to the data attributes, we're also talking about processes at the same time we talk about data. This idea is called encapsulation, the combining of process and data into a single entity. Each class can have both attributes and methods associated with it. Encapsulation is one of three important characteristics associated with the object-oriented approach. The second key concept is inheritance. Inheritance is used to identify higher-level or more general classes of objects. Common sets of attributes and methods can be organized into superclasses. Classes are arranged in a hierarchy whereby the superclasses or general classes are at the top and subclasses or specific classes are at the bottom. Here's another example. In this example, person is a superclass. It contains attributes of last name, first name, address, and home phone. We also have subclasses employee and customer. These have the same attributes as the superclass, last name, first name, address, and home phone, but they also have specific attributes for the subclass, such as hire date and pay grade for employees, and last contact date for customers. Methods can be inherited in the same way as attributes. The third and final key concept of the object-oriented approach is polymorphism. Polymorphism means that the same message can be interpreted differently by different classes of objects. For example, if we have the message insert a new instance, the customer class will interpret that to mean insert a new instance of a customer. The vehicle class will interpret that same message to mean insert a new vehicle. Now that we know some key characteristics of the object-oriented approach, let's talk briefly about which methodology we should use if we're designing with objects. Most object-oriented approaches are associated with an iterative development RAD methodology. They're also sometimes used with Agile. For our project in our class, we're essentially following the waterfall development methodology, so it's not as well suited to taking the object-oriented approach and using objects in our analysis and design. RAD works well for object-oriented approaches because with objects you can easily break things into modules and create the system one piece at a time. So building a prototype or versioning, like we talked about with RAD methodologies in Chapter 2, works really well. OO experts recommend that an object-oriented approach to developing systems should be three things. First, use case driven, that is, use cases are the primary modeling tool. Second, architecture-centric. The underlying architecture of the evolving system drives the specification, construction, and documentation of the system. And third, iterative and incremental. The development undergoes continuous testing throughout the life of the project. Again, you can see why the waterfall method isn't particularly suited to object-oriented design and programming. The Rational Software Corporation has created a specific methodology called the Rational Unified Process, or RUP, that specifically follows the OO approach to analysis, design, and implementation. RUP emphasizes iterative, incremental development and prototyping. It's essentially a specific type of iterative development. As you can see in the diagram, it looks very similar to when we talked about iterative methodologies. The only difference here is that the RUP is based primarily on use cases, and each iteration is based on those use cases developed from the beginning. There are several benefits to an object-oriented approach. First, analysts can break a complex system into small, manageable components. This allows them to work on the components individually and easily piece the components back together to form a system. The modularity makes system development easier to grasp, and modules are easier to share among members of a project team, which leads to enhanced user communication. Reusable pieces are created that can also be plugged into other systems efforts or used as starting points for other projects. You save time because new projects don't have to start from scratch, and learning curves are not as steep. Now that you know a little bit about the object-oriented approach, take a minute to reflect on these questions and then answer them in the forums. Have you learned to program in any object-oriented languages? If so, do these characteristics sound familiar to you? How could object-oriented analysis and design be useful to an organization that codes its systems with object-oriented languages? Do you think the object-oriented approach is valuable even when organizations do not use object-oriented languages? I look forward to seeing your answers to these questions in the forum this week.